The problem with switches like this is that they rely on two pieces of conductive material coming together and making contact very precisely. But because they're mechanical, then what you think's happening when you press or flick a switch is not what happens in reality. What you end up with is this horrible switch bounce, and it can be really annoying. So this is a trace from a particularly naughty switch. Well, in fact, it's a relay, and we'll be using this bad boy in our testing later. But as you can see, when you zoom in like this, the conductive plates actually make and break contact over a period of time, giving you unwanted transitions like this. Now, I have previously posted a similar video to this one, and it's this one here, and I'll leave a link in the description below. Anyhow, in this one, I explained how to use one of these. It's called a Schmidt trigger. But what we're going to look at today is how we can achieve exactly the same thing using a 555 chip. And as you can see here, the transition now is very clean. So let's take a look at how it works. So if you've got a push button like this, a momentary push button, this is a typical way that you would wire it up. On one side you'd have a pull-up resistor, so this output would be high, and then when you press this, then it pulls it down to ground, and then that would go low. Okay, so here it is on the breadboard, nice and simple. So you go, I've got my pull-up resistor there. This would be your output coming across, so that's your resistor, and there's your output there. And this is my switch. Basically, I'm using a timer relay, save me keep pressing the switch. And as I said earlier, this is pretty bad relay here. Yeah, it creates loads of noise and switch bounce, so it's a good demonstration. And then the other side of that is going to ground. So I'm going to put my scope probe there. Let's just wire that up. So measuring the output, connect that to ground. Okay, and we turn the relay on. There you go, that's clicking away. All right, let's have a look at the output on the scope then. So there you go, that's that relay switching away with no debounce on it. Yeah, it's ugly, look. I'll just try and stop it on there and zoom in a bit. Exactly as I showed you before. Spiking up and back down. Yeah, horrible. So we need to get rid of that. And a typical way to absorb some of that switch bounce is to do this, add a capacitor. So that kind of holds the charge during those very erratic bouncing period of the switch. So I'm showing the values this time. So I've got 100k, you probably put a 10k, be fine. 1k there, and I've got a 0.1 microfarad capacitor. So your capacitor charges up through this 1k and your output will go high. Then when you press the switch, your capacitor discharges through that 1k and eventually it'll go low. All right, then on the breadboard, here we go. So there's my 100k that's tied to the supply rail there. That goes into my output. So again, there, 100k, there's the output. And then I've got 1k across here using my timer relay again as the switch, which then goes to ground. It pulls that to ground over here. And there's my 0.1 microfarad capacitor. That's just a little bridge there to join those two up. So let's have a look at the output of that on the scope. There you go. This has got rid of all of that nasty bouncing from the high state to the low state, and it's drawn this out over a period of time. So where you see these steps, that's where it's bounced back to the high state for momentarily, and the capacitor kind of holds its charge. It has started charging back up, but not enough. And then it eventually gets down to 0. Okay, but the problem with this, of course, it's drawn out the fall and rise time to quite a long period. And the device that you're connecting this into may not be happy with this kind of uncertain state. It's neither high nor low. It's taking too long to get down to the low state. So if we take our switch circuit that we just done with the capacitor and add in our 555 chip, as I've shown here. If you're not familiar with the 555 or you don't understand how these internal building blocks work, then you really need to take a look at my previous video, this one I'm showing here, and I'll put a link in the description below. I'll go through all the internal workings of the 555 in a simple way and how you can build an A-stable circuit like a flashing LED or whatever. Anyway, this is the circuit that I'm showing for the debounce arrangement. So we take the output from our switch with capacitor arrangement, and that gets fed into both the trigger and the threshold pins of the 555. Of course, you need to wire up your supply and your ground, and for good practice, you should put a 0.01 microfarad capacitor on your control voltage pin as I've shown there, and reset must be tied high. So let's just take a look at this on the breadboard then, and then we'll come back to this. So there you go, got the same capacitor circuit here with the switch, and the output is not connected to anything at the moment. And then I've wired up the 555 circuit here as I've just shown you, this one. So pin 1 has to go to ground, of course, and pin 8 has to go to your supply rail. Pin 4 has to go to your supply rail also, because that's the reset. If you don't put that connected to anything, then it'll just keep resetting itself. And pin 5 over here, which is the control voltage pin, the data sheet says good practice to put a 0.01 microfarad capacitor to ground on that side. And then you have to wire your threshold and your trigger pin together. So like I've shown here, that's your threshold and your trigger pin there have to be connected together. If you put it like that, then that's basically this connection I've shown there. So what I've got to do now is connect this output into this. So it goes into the output from this side has got to go into your trigger and your threshold pin through that link. So if I just put a jump wire from here, okay, from that output of that, and connect that in there, then that's connected to the threshold and the trigger. So now my output is going to be here on pin 3 of the 555. So let's connect my scope probe into there. Okay, and connect that into ground. And in addition, what I'll do is I'll connect my blue probe over here to show again the relationship with the capacitor. Okay, the capacitor switching over this side. So let's connect that to ground also. All right, let's have a look at that on the scope probers, on the oscilloscope as well then. So there you go, let's trigger in up and down as that relay's clicking away, opening and closing. And we've, as you can see, we've got a nice clean square wave going on. If I just stop that triggering for a moment, there you go, nice square line there. Let's just zoom in a bit. Yeah, you got some ringing because it's all on a breadboard. It's got inductors and capacitance all going on. But we've got a nice clean square wave in general. And let's just put on, let's see if we can catch it on the falling edge now. There we go. Again, nice clean wave there. Zoom in. Yeah, it's still got this ringing, don't worry about that. And yeah, beautiful. But let's just look at the blue trace now, so we can see them in conjunctions. Turn the blue trace on. So what's happening now is that this is the capacitor discharge, and every one of these blips is where the switch has bounced, but the capacitor holds the charge. When it gets down to its 1/3 voltage, 1/3 supply voltage, then the 555 triggers and it goes high. Okay, and it won't drop back down again until we get to the 2/3 voltage as this capacitor charges back up again. So let's catch it on the rising edge now. So there you go, it's reached its 2/3 voltage now, and the 555 has gone down to ground. Now, this is really drawn out, this capacitor charge, because actually 100k, yeah, it's probably a bit big. So the charge time through that 100k is much longer than the discharge with a 1k resistor. But I'll tell you what, let's just change that to a 10k and see what we get. Right, so that's better now. We've got a 10k resistor in there. So let's catch it on the rising edge of this capacitor. So there you go. Once it's reached its 2/3 voltage there, so this is the capacitor charge curve here. Once it reaches 2/3, the 555 triggers and yeah, resets that flip-flop basically, and then goes back down to ground. Let's just turn that off again. And there you go. So that's how you can get a nice, beautiful square wave from a switch and get rid of all that bounce from it. So there you go, that proves that this circuit does indeed work. It gives you a nice square output, even though you've got some horrible load switch over here that's got loads of bounce going on with it. And what's basically going on, if you look at this example of the capacitor discharging here, and these little steps are where the switch was bouncing, the 555 implements these thresholds. You got a 1/3 voltage threshold here and a 2/3 voltage threshold here. You really need to look at my previous video if you don't actually follow that part. But once capacitor discharges down below your 1/3 voltage, then the 555 output will go high and it'll be latched high. So you've got to bear in mind that the output is actually inverted here, but ignore that for the time being. And once it gets down to that point, if the charge here glitched and suddenly went up above this line momentarily, for whatever reason, it doesn't matter. It won't change the output until it reaches the 2/3 voltage. So once it gets up here, the same thing occurs. It will latch in a low state on the output, and then if it drops down inadvertently for whatever reason, it won't change. So what this is called is hysteresis. It gives you kind of a threshold limits between your high and low state. So I will leave a copy of this circuit that you can download. I put a link in the description below. Do what you like with it. Anyway, that's the 555 used as effectively a Schmitt trigger. It's doing the same thing as a Schmitt trigger. And if you found this video useful, then please click the like button. And if you haven't done so already, then please click subscribe too. All right, catch you later.